Okay, welcome to FRQ 5 for set number 6. So, sorry for all the drawing. Let me erase this real quick. Okay, so it wants us to part A wants us to say which way, left or right, will the system move. Okay, so I'm going to kind of cut it like this, so left side, right side. Okay, so on the left, the only force you have is Fg1 because of mass 1, and that's equal to m1g, so mass is 8, 9.8 for gravity, 8.4 on your left side, we'll call it. Okay, moving on to the right side. So now we have 2. So we have Fg2. Draw those components out. Okay, so Fgx or Fg2x. Okay, and that's gonna so Fg2x. This needs to be a subscript. Okay, so that's 1, and then we have this Fg, so plus Fg3 because mass 3, and then this was 2 because mass 2. Let's go ahead and find those. So that's m2 sine opposite sine theta. Drew over it. 45 plus 5 times 9.8. Okay. So 5 times 9.8 sine. Why do I keep doing that? Okay. So let's go ahead. 5 times 9.8. You can see that. 5 times 9.8. And then this one is, so it's going to be 49 sine 34.65. Okay. And then you add the 2. Okay, so on the left side, you have this force that wants to go this way. Okay, so we called it our left side because that's what side it's going to pull. It's going to pull on the left side. We found that to be 78.4. Now, looking at our right side, because these forces want to pull this way, to the right. So we go ahead and add them, and we find it to be 83.65. Now that's bigger than the left side, so that tells us that the system is going to be moving right. Okay, part B. What is the speed of m3 after it has traveled a total distance of 0.5 meters? Okay, so let's go ahead and find acceleration. So we can go ahead and find the acceleration for the whole system. So we know that this side, Fg2x plus Fg3 is bigger, and this is smaller. Big minus small. G1 is equal to ma. So we can just plug these numbers in. 83.65 minus 78.4, and total mass 5, 5, 10 plus 8, 18A. Okay. So we get 83.65 minus 78.4 equals 5.25. We'll go ahead and divide. A is equal to, oops. Oops. Didn't round correctly. Alright. So, we found acceleration. Let's just find speed. Okay. We can go ahead and set up common form. Okay, and there is no VI because it starts from rest. So 2 our A, and it gave us, oh, this should be delta Y, excuse me. 0.5. Alright, go ahead and plug this in our calculator. Solve for VF. And that is our answer. Okay, part C. Okay. Part C, calculate the time it takes for it to travel to 0.5. Alright. So, using what we have, we can set up acceleration is equal to VF minus VI over T. And we can go ahead and move things around to solve for T, and remember there is no VI. So we just get VF over A. And let's go ahead and plug that in. So that would be 0.5 over 0.292. That gets you 1.85 seconds. Alright, on to part D. Using a ratio, find the time it takes for M3 to travel an additional 0.5. The second 0.5 from 0.5 to 1. Okay. So, let's go ahead and find the second time. So, let's go ahead and we can set up our distance formula. Okay. And it's very important here that we plug in everything correctly. Okay. So our delta y is going to be negative 0.5 because it's going down. Okay, and our VI. Okay, so M3 is moving down, so actually going back to part B, this needs to be negative because it's going down. Sorry about that. Okay, so our VI is going to be negative 0.54t plus 1/2. And then we're going to make our acceleration negative as well because we're going down. We're just looking at M3, we're going down. So that means our acceleration is negative. We're just using the same acceleration, but now we're just focusing on mass 3, and that makes it negative because the mass is going down. Okay, so points. So how? All right, so we get a quadratic move. Well, actually, we need to move things around so we can get a quadratic. Negative. Dang decimals. Okay, 0.1. Okay. Go ahead and plug this into a quadratic solver. 2 degrees. Okay. We have to make sure we have we're plugging them in correctly too. So negative 0.146, negative 0.54, and 0.5. So you get t is equal to 0.6. Oops. Wait. 0. Oh my goodness. 0.767. There we go. Okay. So that is the new time from okay, so we're starting from after it has already moved 0.5. So that's what we just found. We found the time it takes for it to move an additional 0.5. So we can take our new time, 0.767, and put it over the first time we got, 0.85, and you get, let's see, go back to, okay, so 0.767 divided by 1.85, you get 0.41. And now we can put this into a ratio. What that tells us is T2 is equal to 0.41 of T1. Okay. On to part E. Okay. Part E. Find the speed first traveled, the total distance. Okay, so it wants us to do the same thing, but now with speed. Okay. Oh my goodness, I need to work on my reading school. This isn't negative. I just got so confused with all that. Okay, so let's go back to B again. So I put negative because I was saying it's going down. We don't need to do that though, however, because B is asking for speed. Speed cannot be negative. Okay. Sorry about that. I'm like all over the place with this one. Just so many things changing. Okay. Okay, so E, now we're doing ratios by using speed after it has traveled the 1 meter. Okay. So let's go ahead and find the VF after it has traveled 1 meter. We can use common form. Okay, start some rest. Okay, and it gave us, and we found acceleration. Okay. Okay, so we found the VF after it has traveled the total 1 meter, all of the 1 meter. So again, we can use our new one, put it over our old one of, you can see that, okay. Get, oops, 4. So using that number we just got, we can make our ratio. So that means put speed 2, right? Wants us to find speed. Yeah, speed 2 is going to be equal to 1.14 of speed 1. Alright. Grab another piece of paper. Oh, actually. Okay, we can actually quickly fit F into here. So F wants us to find the acceleration of M2. Now, we found the acceleration of the whole system. So that just means acceleration is going to be equal for M2. So acceleration whole is going to be equal to acceleration of M2. So, okay, so 0.292 meters per second is equal to acceleration of M2. Alright, now we get in a piece of paper. Okay, part G wants us to calculate the tensions in the string connecting M1 and M2. So let's go ahead and draw our tensions. These arrows are terrible. Okay, tension, cool. So so we're gonna go ahead and pick a block to look at when finding tension. So I'm gonna go ahead and look at block of mass 1. Okay, so let's go ahead. So we set up Newton's law, and so let's use our forces. So T is going to be greater. Remember, big minus small. And T is going to be greater because remember we're moving right. Okay, so that means T is going to be what's pulling this block. Okay, so let's go ahead and just expand everything. We found acceleration, as we recall. Okay, just keep simplifying. Okay, and we're solving for tension, so we can just go ahead and move this over. So add it, and you find that tension is equal to 80.736 newtons. Okay, last part, H. Okay, so it wants us to find the coefficient of friction along the surface of the incline that would keep the system stationary. Okay, let's go ahead, set up Newton's. Excuse me. Okay. If our system is stationary, it means it isn't moving, and that means there is no A. So sigma F, and we just can go ahead and plug in or expand all of our forces. So FG3 minus, or not minus, excuse me, plus FG2X. Now, and then minus F of K, because that's going to be on mass 2, and then minus F of G1. That's all going to be equal to 0. Alright, let's go ahead and expand everything. So, okay, we can use this that we already did previously. Okay. So when it comes to F of K, we know that for inclines, okay, in general, F of K is equal to Fn mu, correct? And then on inclines, F of n is equal to Fgy. So for this, we can just write Fgy. We need to write this as 2 though. It's Fg2y mu. Okay, and we can expand this into G. That's sine for x, and we want y, that means it's going to be cosine 45 minus m1g. Okay. Now we can go ahead and plug in all our numbers. M3, 5, 8, plus 5, 8, minus 8. Oh, wait a minute. I totally forgot to put mu in here. Let's quickly put this in right here, mu. Because remember, we're looking for mu, so we need to have that, and so F of K would expand. I just forgot to put mu. Okay, sorry about that. Okay, and now we can just plug things into our calculator. And since the angle's 45, we know that this is going to be the same because it's 5 times 9.8, and then it's just cosine and sine, but angle's 45, so we know it's going to be the same. I need to plug it into my calculator multiple times. Okay. So what we can do now is combine everything. So 49 plus 34.65 minus 78.4. And again, this is, we are kind of repeating this. I guess you could have started, but it's best to show all your work. But, what we are essentially getting is this again. We got the 83.65, so this side minus the 78.4, which was this side, but now we have to find a mu, so we need to account for F of K. So you could have, I guess, shortcutted and started from that, but it's best to show all work. Okay, so Let's move that to the other side so we can get it by itself. Okay, we find mu to be equal to 0.152. And that is it. That concludes FRQ number 5.